Hello everyone and welcome to our today's class. It is our second and last lesson on the topic the turning effect of a force. So as it is our norm, let me commence by giving you the quote of the day, which states that we feel frustrated when our challenge or task is far much greater than our level of skills. Conversely, we feel bored when our level of skills is far much greater than our challenge or task. So we'll discuss that quote at the end of our class today. So today we'll be looking about the parallel forces. So what do we mean by the word parallel? So we say two or more lines or even objects are parallel if they are equidistant at all points. That is, the distance from one of the lines to the other is exactly the same at all points within that particular line. So if we are talking of parallel forces, it means the line of action of the force is exactly parallel to each other. Remember, parallel forces or parallel lines never intersect each other. So let's start by looking at an example involving parallel forces. So the example actually reads that the figure below shows a uniform meter rule of weight 1.6 Newton supported by a spring balance at the 32 centimeter mark, full stop. The meter rule is balanced horizontally by a 1.2 Newton weight suspended as shown below. Then we are required to find the point where the 1.2 Newton is actually suspended. So to sketch our diagram here, one, we are told that the figure below shows a uniform meter rule. So if it is a uniform meter rule, then we know that a meter rule, it is called a meter rule because its total length is actually 1 meter, which is equivalent to 100 centimeters. So if the figure shows a uniform meter rule of weight 1.6 Newton, remember the weight of a body will always act at its position of center of gravity or at its geometric center. So if it has a weight of 1.6 Newton, then the weight of 1.6 Newton will act at the 50 centimeter mark. Why? Because the 50 centimeter mark represents the midpoint or the position of center of gravity for a meter rule, which is actually equivalent to 100 centimeters. So you take 100 centimeters divided by 2, you actually get 50 centimeters. So the 50 centimeters, that is where the whole weight of that particular meter rule will actually act from. Then we are told that it is supported by a spring balance at the 32 centimeter mark. So you can see my spring balance is actually suspended at the 32 centimeter mark. Then the meter rule is balanced horizontally by a 1.2 Newton weight. So we have a 1.2 Newton weight here, which is suspended as shown below. So we are required to find the point where the 1.2 Newton weight will actually be suspended. So to find that weight, we will apply the principle of moments, which actually stated that the sum of clockwise moments must be equal to the sum of anticlockwise moments. That is, if a system is in equilibrium and about the same point. So for this case, actually our spring here acts as our pivot or the turning point, or sometimes we call it the fulcrum. So that means when we'll be measuring the perpendicular distance from a given force, we'll be measuring them from actually the spring, which is acting as our pivot, because actually this bar is balancing, it is suspended horizontally by a spring. So actually the point where the spring is attached itself on the meter rule, this represents the turning point or our what we call the fulcrum. So from the principle of moments, sum of clockwise moments must be equal to the sum of anti-clockwise moments. Then we did say that clockwise moments are those moments or will be provided by the forces that will cause our meter rule to move in the clockwise direction. So remember, the clockwise direction is a direction similar to the direction of a normal clock, wall clock, that is the minute hand clock and the hour clock of a normal wall clock. So if our force of 1.6 Newton is acting from this side, and this is where we have our pivot or the turning point or the spring actually, so it means this force, because it is acting downwards, that is the 1.6 Newton about the spring balance, which is acting as our pivot, it will cause the bar to bend or to move in this direction. So actually this direction is the clockwise direction, because it is a direction similar to that of the minute hand and the hour hand of a normal wall clock. So because the 1.6 Newton force is causing the bar to move in the clockwise direction, therefore it will contribute to the anti-clockwise moments. So remember, we did say that moment is given by the product of the force applied and the perpendicular distance of that force measured from the pivot to the line of action of that particular force. So if in the clockwise moment is provided by one force, which is the 1.6 Newton, so its moment will actually be 1.6 Newton times its perpendicular distance, that is from the pivot or the spring which is acting as our pivot. So the perpendicular distance of this 1.6 Newton force from the pivot will be the 50 minus 32, because the force is actually suspended at the weight is suspended at the 50 centimeter mark, while the spring is suspended at the 32 centimeter mark. So to find the perpendicular distance from the pivot or the spring to the line of action of the 1.6 Newton force, we will simply take 50 centimeters minus 32 centimeters. So remember, you just need to know that the weight will always act at the center. There are not all questions where you will be indicated that this is the 50 centimeter mark. So if maybe it is a bar of 50 centimeters, if its total length is 50 centimeters, then the total weight will act at the 25 centimeter mark. That is at the middle or at the midpoint, provided actually the bar is uniform. Provided the bar is uniform. So the perpendicular distance will be 50 minus 32 centimeter, but we did say that the perpendicular distance is a length, and therefore the SI unit for length is meters. Therefore we need to convert it into meters. So we'll take actually the 1.6 Newton force times the 50 minus 32, then we are dividing by 100. So remember, 100 centimeters is equals to 1 meter. So what about 50 minus 32 centimeters? So 50 minus 32, you simply get 18 centimeters. So 18 centimeters divided by 100 centimeters, you will actually get 0.18 meters. So this is just to convert it into SI units. Alternatively, on this other hand, the sum of anti-clockwise moments will be provided by a force which is causing the bar to move in the anti-clockwise direction. So remember, anti-clockwise direction, that is a direction that is opposite to the minute hand and the hour hand of a normal wall clock. So the anti-clockwise moment in this case will be provided by the 1.2 Newton force. Why? Because if this is our turning point or the pivot, then the effect of the 1.2 Newton force on this bar, it will actually cause this bar to bend downwards or to move in this particular direction. That is relative to our pivot, which is actually the spring. So the 1.2 Newton force, it will cause the bar to bend downwards or to move in this direction, because this is our pivot. So actually this direction is the anti-clockwise direction. So because it is in the it is causing the bar to move in the anti-clockwise direction, therefore we categorize it under the anti-clockwise moments. So if we take this force, that is 1.2 Newton times its perpendicular distance, that is the distance from where the force is suspended measured from the pivot, that is the 32 minus this particular distance from the 1.2 Newton force to actually the pivot or our spring. This will be the perpendicular distance. So that perpendicular distance, we are denoting it by d 1.2 Newton. So we are saying that the anti-clockwise moment will be force times the perpendicular distance from the 1.2 Newton force measured from the pivot or the turning point. So that we have force, which is 1.2 Newton, times the perpendicular distance, which is actually the unknown that we are actually looking for. Then after substituting the values, 1.6 times 50 minus 32, you get 18. 18 divided by 100, you get 0.18. So this is actually in meters, because remember that also the SI unit for moment, we did say it is Newton meter. So that tells you that the force has to be in newtons, whereas the distance has to be in meters, which are actually the SI units for length. So we have 1.6 times 0.18, which is equivalent to 1.2. So remember, 1.2 times d 1.2 Newton, you get 1.2 d Newton. Then I make d 1.2 Newton the subject of the formula. That means I will divide both sides by 1.2. I also divide this side by 1.2, so that I'm remaining with d 1.2 Newton on this side being equal to 1.6 times 0.18, then divide by 1.2. So you compute this one using a calculator, you actually obtain 0.24 meters. So remember, in centimeters, you simply multiply by 100. So it is d 1.2 Newton meter. Newton is actually equivalent to 0.24 meters, or simply 24 centimeters. 24 centimeters. Therefore, remember, we are not asked the perpendicular distance from the pivot to the line of action of the 1.2 Newton force. Instead, we are asked to find the point where it is suspended. So in short, they want us to find the mark where the 1.2 Newton force will be suspended such that the bar remains, or the meter rule remains, horizontally balanced. So here, because the distance from the 1.2 Newton force to the 32 centimeter mark is actually 0.24 meters or 24 centimeters, therefore it means the 1.2 Newton force should be suspended at. So if this is actually 32 centimeter mark, then the distance from 32 actually up to here is 24 centimeters. So to actually get the mark where the 1.2 Newton force will be suspended, we'll just take the 32 centimeters, then we less or we subtract the 24 centimeters. So you take 32 centimeters minus 24 centimeters, it will actually take you back here to 1.2. So 32 minus 24, you simply get 8 centimeters. So it means our 1.2 Newton force should be suspended at the 8 centimeter mark for the meter rule to actually balance horizontally. That is as shown in the diagram. Then part B, we are required to find the reading on the spring balance. So remember, the spring balance, it is the system is at equilibrium, meaning the sum of upward forces must be equal to the total downward forces. So the total downward forces is provided by the 1.2 Newton weight and the weight of the bar of the meter rule, which is 1.6 Newton. So the total downward weight or the total downward force must be equal to the total upward force. So the total upward force is simply the force provided by the stretched spring, or the spring which is actually holding this bar horizontally. So total upward force will be equal to the total downward force. So the spring will read, its reading will be equal to the reading of the total downward force, and the downward force is given by 1.2 Newton force plus 1.6 Newton force. Therefore our spring reads 1.6 plus 1.2, which is actually 2.8 Newton. So the spring reads 2.8 Newton. Next, we look at what we call equal parallel forces in opposite direction. So we need to define what we mean by a couple in physics, or simply parallel forces in physics. So remember, we said that when two or more things are parallel, it means they are equidistant, or they are at the distance between any 2 points along those lines should exactly be equal, or should exactly be the same. Now, what is a couple? So in physics, a couple refers to a pair of forces which are equal in magnitude, parallel, and which are moving in opposite direction. So that is what we mean by a couple. So if you are asked to define what we mean by a couple in physics, you simply say that a couple refers to a pair of parallel forces, a pair of equal forces, that is forces which have equal magnitude, 2 moving in which are parallel to each other, and 3 they must be moving in opposite direction. So these are the 3 conditions for a pair of forces to be categorized as a couple. So remember, a pair means a couple will be 2 forces. A pair means 2. So we are saying that a couple refers to a pair of forces which are equal in magnitude, parallel to each other, and lastly which are moving in opposite directions. So we look at an example of couple forces. So I'll just highlight a few. So example of couple forces in real life situation. One involves the forces applied on the wheel spanner, that is in tightening or untightening or loosening a nut. Then the second pair of couple forces is in forces applied when opening or closing a tap. Then the third example of couple forces in action is the forces applied on the steering wheel of a car, that is when going round a circular bend. So actually, in all those above examples, a pair of antiparallel forces produce a turning effect. They produce a turning effect. So we look at an example to see how to identify couple forces, that is in a given question. So the question actually reads that identify the couple among these forces. Identify the couple among these forces. So to identify a couple, you just need to know the definition or the conditions that satisfy to a pair of forces to be called a couple. So we are saying that a couple refers to a pair of forces which are equal in magnitude, 2 parallel to each other and moving in opposite directions. So here refers to is a question requiring us to find a couple. So we are asked to identify the couple among these forces. So One, we can investigate the relationship between force F1 and force F2. So you look at force F1 and force F2, they are intersecting each other. So such forces which are intersecting each other, they are not actually parallel to each other. So that tells you force F1 and F2 cannot be called a couple forces. Why? Because they are not parallel to each other. 2, force F1 is 3 Newton while F2 is 2 Newton. So because this is 3 Newton and this is 2 Newton, it means those forces are not equal in magnitude. So again, it is not a couple forces. Then the two forces are moving in the same direction. So we've said that couple forces must be moving in opposite direction. Therefore, force F1 and F2, they are not couple forces. So we can investigate force F1 and maybe force F6. As you can see, force F1 is moving in this direction, whereas force F6 is moving downwards. So F1 and F6, they are forces moving in opposite direction. So they satisfy the third condition, that the forces are moving in opposite direction. Then force F1 has a magnitude of 3 Newton, while F6 also has a magnitude of 3 Newton. So the forces have equal magnitude. So they have satisfied the first condition. And lastly, the force F1 and force F6, they are parallel to each other. That is, you extrapolate the line of force, the line of action of force F6, and you also extrapolate the line of action of force F1. You realize that those lines can never intersect each other, or any 2 points among those two lines will always be equidistant or at equal distances from each other. Therefore, we say that F1 and F6, they are actually parallel to each other. So because force F1 and F6, they satisfy all the 3 conditions, therefore we conclude that force F1 and force F6, they form a couple. They form a couple. So remember, a couple consists of a pair of forces. So force F1 and force F6 is simply a couple. So the reason we are saying is because 1, the forces are equal in magnitude. That is, this one is 3 Newton, this is also 3 Newton. So they are equal in magnitude. 2, the forces are parallel to each other. That is, you extrapolate F1 and the line of action of F6, those lines can never intersect each other. Therefore, the two forces are parallel. Then the forces are moving in opposite direction. Force F1 is moving upwards, whereas force F6 is moving downwards. So they are satisfying all the 3 conditions. Therefore, we conclude that F1 and F2 is couple, represents a couple. Then we investigate maybe force F2 and maybe something like force F7. You look at force F2, it is moving in this direction, that is towards my left hand, whereas force F7 is moving towards the right hand. So the forces are moving in opposite direction. So they have satisfied one of the conditions. Then force F2, it has a magnitude of 2 Newton, while force F7 has a magnitude of 4 Newton. So because this one has a magnitude of 4 Newton, while this one has a magnitude of 2 Newton, therefore it means the forces are of different magnitudes. Therefore the forces are not equal. So because they don't satisfy the first condition, therefore we conclude that force F2 and force F7 do not form a couple. Then maybe we investigate force F4 and maybe force F5. So force F4 is actually moving upwards, while force F5 is moving downwards. So the two forces are moving in opposite directions. So they have satisfied one of the conditions. Then force F4 is actually parallel to force F5. That is, you extrapolate these lines, they will never intersect each other. So the two forces are parallel to each other. Then lastly, force F4 has a magnitude of 5 Newton, while force F5 has a magnitude of 5 Newton. So they have similar magnitude, meaning that the two forces are equal. So the force F4 and F5, they are equal. That is, they are both 5 Newton. Force F4 and F5, they are parallel to each other. That is, these two lines can never intersect each other, even when extrapolated. Then force F4 and F5, they are moving in opposite direction. That is, F4 is moving upwards, whereas F5 is moving downwards. So because they satisfy all the 3 conditions for them to be categorized as a couple, therefore we conclude that force F4 and F5, they form a what? A couple. Then we also look at force F5 and F9. So force F5 is moving downwards, force F9 is moving upward. So they are moving in opposite direction. Force F9 is 5 Newton. Force F5 also has a magnitude of 5 Newton. So the two forces are equal. Then force F5 and F9, they are actually parallel to each other, as you can see here. You extrapolate these lines, they will never intersect or meet each other. So because they have satisfied all the 3 conditions, we are also concluding that F5 and F9 is a pair of couple forces. So maybe we look at a different pair. For example, we try to investigate force F8 and maybe F3. So you realize force F3 is moving upwards, force F8 is also moving upwards. So they are moving in a same direction, in similar direction. So they are not oppositely directed. Therefore, F3 and F8 cannot be categorized as a couple forces. So for them to be categorized as a couple forces, they must satisfy all the three conditions. They must be of equal magnitude, 2 moving parallel to each other, and 3 moving in opposite direction. So F3 and F8 do not form a couple simply because they are moving in the same direction. Although they are equal, 7 Newton, and they are also parallel to each other, but they are moving in a similar direction. So maybe you also look at a different pair of forces. For example, we can investigate maybe F1 and F5. So F1 is moving upwards, whereas F5 is moving downwards. But you look at force F5 and F1, you extrapolate this line of F1, and you also extrapolate this line of F5, they will intersect somewhere. So the two lines or the two forces are not parallel to each other. Therefore, they cannot be categorized as a couple. Further, force F1 is 3 Newton, F5 is 5 Newton. So they are of different magnitude. So they are not they do not form a couple forces. So in short, we've said that a couple forces, simply a couple refers to a pair of forces which are equal in magnitude, 2 parallel to each other, and lastly moving in opposite directions. Then we look at what we call moment of antiparallel forces, or what we are calling the couple forces. So antiparallel simply means these are two forces which are parallel to each other but moving in opposite direction. So moment of antiparallel forces. So how do we find the moment of antiparallel forces in calculation? So moment of antiparallel forces, or simply couple, is given by the product of one of the forces and the perpendicular distance between the two forces. So remember, couple forces will have equal magnitudes. So there is no need of multiplying F1 D1 plus must be equal to F2 D2. So because the forces are the same, you just take the product in mathematics means multiplication. So it is the product of one of the couple force and the perpendicular distance between the two couple forces. So we look at an example to demonstrate that point. So the example reads that determine the moment of the couple shown below. So here is our bar here. Probably it is a meter rule because it is running from 0 centimeter mark up to the 100 centimeter mark, or it is simply 1 meter in length. So one of the couple forces is pivoted or is suspended at the 3.6 Newton and it is moving upwards. A force of 3.6 Newton is suspended at the 12 centimeter mark, while 3.6 Newton, which is moving downwards, it is also suspended at the 80 centimeter mark. So we are required to determine the moment of the couple. So we are saying that moment of the couple is the product of one of the forces and the perpendicular distance between the two forces which are forming the couple. So moment of the couple is equals to one of the forces times. Remember, times is what we are calling the product. Product in mathematics actually means multiplication, because remember we did say that there is a very close correlation between physics and mathematics, because most concepts in physics are actually expressed mathematically. So moment of the couple is equals to one of the forces times the perpendicular distance between the couple. So one of the forces is 3.6 Newton. This one is also 3.6 Newton. So it will be 3.6 Newton times the perpendicular distance between the couple. So the first couple is at the 12 centimeter mark, while the second couple force is at the 80 centimeter mark. So the perpendicular distance between the two couple forces will simply be 80 centimeters minus 12 centimeter, because we want this distance between these two couple forces. So it will be 80 minus 12 centimeters. But because it is in centimeters, but we did say that moment has to be Newton meter, therefore we convert the length into meter. So 80 minus 12 divided by 100, because 100 centimeters is equals to 1 meter. So what about 80 minus 12 centimeters? So this will be 80 minus 12 centimeters over 100 centimeters times 1 meter. So you compute this one using a calculator, you will I expect you to find 2.448 Newton meter. So that is how to behave when you are given a calculation involving couple or anti-parallel forces. Next, we look at application of anti-parallel forces. Application of anti-parallel or simply coupled forces. So where do we apply the anti-parallel forces or coupled forces in real life situations? So we say that anti-parallel simply means the two forces are parallel to each other, but they are moving in opposite direction. So if they are of similar magnitude, then we simply conclude that they are coupled forces. So the first application is in the steering wheel, So cars are made to turn around corners by exerting two equal and opposite forces, that is F, which are acting tangentially. So they are acting along a tangent, as you can see this F1 and also this force actually here, which act on a tangent to the steering wheel. They act on a tangent. So the wheel is pivoted at its center. So this is the center of the wheel or the turning point, and rotates about that particular center in the clockwise direction. So like in this case, when F1 is pulled downwards, when your hand holding this steering wheel of a car or a vehicle, when it is pulled down, actually the other hand actually pushes this one upwards, such that the wheel, because this is the turning point, the wheel actually rotates in this direction, which is the clockwise direction. So the two forces, they form a moment of anti-parallel forces about the center. So assuming the diameter, that is the distance from this force to this particular force, or assuming the diameter of the wheel is simply d, then the moment about this particular turning point will simply be given by the force, one of the forces, times the d, times the diameter between the diameter of the wheel. Then another application is in the water taps. So a water tap is opened or closed by applying two equal and opposite forces, or simply anti-parallel forces. The two forces produce moment about the axis of rotation. So like in this case, this is the axis of rotation. So this part is actually movable. So like in part A here, that is in opening the tap, the force produce an anti-clockwise turning effect, hence opening the tap. That is when one of the hand is pushed upwards, then the other one is pushed downwards. Actually, this bar or the tap will rotate in this direction, which is the anti-clockwise direction. So this rotation actually opens the tap. However, if now the application of the force is reversed, such that this force is pushed, this end is pushed downwards, while this one is pushed upwards, actually this causes the tap to move in the clockwise direction. So this motion actually closes the tap. So this is an application of anti-parallel forces. Then anti-parallel forces are also applied in the bicycle handle. That is, when a bicycle is turned around a bend with both hands on the handlebar, two equal and opposite forces are applied. For example, if you want to take a bend, or you want to rotate the bicycle, or you are taking a corner, you want the bicycle to move towards this direction, that is to the right hand side, you actually pull this handle outwards, whereas you push this one inwards. So actually that motion, because this part is movable, which is acting as our pivot, actually the bicycle will turn towards this direction, or it will move in the clockwise direction. So also, if you want it to turn in the other direction, you now reverse. You push this handle inwards, whereas this one you push it outwards. So that is an application of anti-parallel forces. So if you want to find the moment, you simply take one of the forces in your hand times the perpendicular distance between this handle and this actually handle here. So that will give you the moment of the anti-parallel forces. So anti-parallel forces and their moments are also applied in water sprinklers and even in wheel spanners, whereby you will find when you push it on one side, the other force will be pushed on the reverse or on the opposite side, hence therefore producing a turning effect. And lastly, I give you an exercise here which I recommend that students should try to see whether they understood what we've just explained. So question 1 reads that determine the moment of the couple shown below, given that the bar is a uniform half meter rule. So the expected answer is 6 Newton meter. So maybe just to give you a hint, a uniform half meter rule simply means it is a half of the meter rule. So remember, a meter rule is usually 1 meter in length, or 100 centimeters. So if you are talking of half a meter rule, it means the total length of this bar will be 50 centimeters or 0.5 meters. So that is just a hint. Then question 2 reads, determine how far from the 0.18 Newton weight, determine how far from the 0.1 Newton weight a pivot should be placed in order to balance the meter rule. So the expected answer is actually 47.69 centimeters. So try working out that one. Then in case you have problems in solving that, just drop a comment on my on the comment section of this particular video. Then I'll be there to offer assistance where necessary. So we've come to the end of our class today, but we cannot end without discussing the quote of the day. So if we can remind ourselves, the quote of the day stated that it gave us situations, or it explained to us why we get frustrated and why we get bored. So the quote said that we feel frustrated when our challenge or task is far much greater than our level of skills. Then conversely, that we feel or we get bored when our level of skills is far much greater than our challenge or our task. Now, what should we do in order to avoid getting bored or even getting frustrated? So to avoid getting bored or getting frustrated, most of us, that is in the real life situation, most of us would wish that the challenge was actually smaller, or the task given to us was actually smaller, so that in any case our level of skills will always be greater than our challenge or our level of task. But what is the problem for this wish being fulfilled? So the problem with fulfilling this wish is that it will constrain us. It constrains us from growing our skills. Why? Because our challenge is actually small. Now the question is, what should we do in order to continue growing our skills, but at the same time avoiding getting both frustrated and getting bored? So the answer is simple. Whenever you feel bored, that is when your level of skills is far much greater than your challenge or your task, what you need to do is to raise your challenge or to increase your task or your challenge in such a way that actually the skills, the high skills that you have, they match the level of your challenge. So whenever your skills matches your level of challenge, then in that case you will never feel bored. Why? Because boredom actually comes whenever your skills are far much higher than your challenge. So do not look for a smaller challenge. Instead, increase or raise your level of challenge or task. Then, when you feel frustrated, that is when your challenge or task is far much greater than your level of skills or expertise, then in this case what you need to do is that actually do not get frustrated because your skills are low. What you need to do is to work on your skills. You need to raise your level of skills to the extent that the skills that you have, they match the level of your task or your challenge. So remember, whenever your skills are lower than your task or your challenge, you will always feel frustrated. Why? Because the skills that you have cannot achieve that challenge. So instead of complaining, work on your skills. Raise your skills to the extent that it matches the level of your challenge or the level of your task. And lastly, do not wish and pray for smaller challenges in life. Instead, wish and pray for stronger backs and even stronger mental strength, which will help you to overcome those huge challenges. Because you will never grow unless you learn how to overcome huge challenges in life. So don't run away from the challenges. Instead, learn through those challenges. Learn through the hardships. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.